Now, can you hear me?
Gregor, this is Will. I can hear you.
Okay. Sorry for the delay. There was some confusion. Seemingly only the first one to enter the meeting room is the host, but now it should be solved. So, and I should have the share here, shouldn't I? Am I sharing the right thing here? Yes. So welcome everyone to this first webinar of a series of 4 webinars on the outcome of IEA Wind TCP Task 36. And we'll be 2 persons presenting today and taking questions. That's me, Gregor Giebel, the one on the left of that picture, and Will Shaw, the gentleman on the right. I'm from DTU Wind Energy here in Denmark, and Will is from Pacific Northwest National Laboratory in the US, currently in Boulder. Let's start at the beginning. What is the IEA? The IEA was founded, the International Energy Agency was founded by the predominantly Western industrial countries in the aftermath of the oil shock. So in 1973, oil got scarce and cars were in long queues on the gas stations. And in Europe, you had the iconic picture of the car-free Sundays. So a lot of the industrial countries, mainly OECD, came together and said, we have to do something about our dependency on oil. And one of the things that the IEA then set up was a lot of different so-called technology collaboration programs. And a lot of them are in renewable energy. You can see them here on the right. Some on photovoltaics, hydrogen, hydropower, and so on. And of course, the wind TCP. IEA Wind was actually founded in 1977 and contains most of the countries with sizable wind power. In next year or so, also South Africa should join. And you can see it's, I think, 70 or 80% of the world market for wind power that is currently part of the IEA Wind. Not all of those countries are part of the forecasting task. The forecasting task is having 13 members. So please have a look whether your own country is part of it. Probably you know that already anyway. IEA Wind also has several active tasks at the moment. A lot in technology development, some in wind flow, some in connection with the power system, and some in the wider area of wind energy and society. Many more details of this you can find on ieawind.org. And we're not an island. We're actually collaborating with some of the other tasks here. And most recently, we had a common workshop of forecasting for wind energy together with the LiDAR task here at Risø, where we looked into how to use LiDARs, radars, or scatter for very short-term forecasts, very short-term being half a minute to 15, maybe 30 minutes. The slides are available from the workshop website, and the complete workshop is actually on YouTube. And there will be a paper that's currently being written by several people here from the task, Laura, Ines, me, David Schlipf, who has been the operating agent of the LiDAR task, Alpatil, quite recently, and several others. While I'm mentioning the YouTube channel, that's where we afterwards are going also to have the recordings of these webinars. So there's a second chance to see them or to point to your colleagues. who didn't have the chance to see it. What are we talking about if we look at forecasts? Not so long ago, the Met Office had a quite good show of what the different stakeholders were for different forecasts. And you see operators obviously need forecasts for any sort of length. And I extended that to the minute and second range. While you have the traders with typically day ahead horizons, that's the main focus of trading at the moment. Grid management is even the intraday and day ahead. That is very important, though the minute scale actually comes more and more into focus now, and so on. So there's several stakeholders that need forecasts. How do we do these forecasts? We start out with numeric. Then the data from that goes into a forecasting model. That's typically an either estimated or a calculated power curve for the wind farm in question, sometimes also for the entire region in question. Usually you get some online data to tune this power curve, or also to get the very short-term forecasts well done in a recursive fashion. Sometimes you also use data from usable for microscale models, because the numerical weather prediction usually has a kilometer scale, several kilometer scale grid. And if you have complex terrain, then you would either need very good statistical methods that take the anisotropy of the terrain into account, or you do it with a microscale model. Then you serve these to the end user either as a deterministic forecast or as quantiles, and those two would be the very standard ways of doing this now. Or depending on the use case, you can also deliver them as scenarios. So the users are then, for example, grid companies or traders, or for the maybe a bit longer term forecasts, also people doing maintenance scheduling. So essentially, we got three different groups then that are involved in doing these forecasts, or doing or using these forecasts. One of them is all the big weather centers doing the numerical weather prediction. Some smaller forecasting, specialized forecasting companies actually also run their own weather model. So they would be all in this bracket. Then we have a large number of companies delivering forecasting services. They are typically coming from a statistical angle, but sometimes also from the meteorology angle. But the main thing is that they take the data, take the weather data, do something with it, and then deliver it as a service to the end user. The end user is typically system operators. In the US, obviously, the ISOs, in Europe, the TSOs, or operators of the turbines, or just directly traders. So we got these three different groups, and we made the task so that we have three different work packages that are fitting the tasks in this way. We have work package 1, where we have the coordination of numerical weather prediction advances, where we're trying to get some additional data that would be useful for either verification or for assimilation of data, and we are trying to do some benchmarks. Then in the second work package, we're looking at how a sane vendor selection process looks like. Look at the standard evaluation protocols, and again at benchmark data. And then we look at how all this data that is in these forecasts is actually used best by the end users. So we're just ending the first phase of the task that ran from 2016 to 2018, and last month the IEA Wind Exco approved the second phase of the task. So then the task will also run from 2019 to 2021. And with that, we're going into work package 1, where Will Shaw is actually not only the cooperating agent of the task, but also the co-lead of work package 1.
Yes, thank you, Gregor. And I am the co-lead of work package 1 with Helmut Frank of Deutsche Wetterdienst. And as you see in the slide, are both of our smiling faces there. The purpose of the first work package, with its focus on numerical weather prediction, is to coordinate numerical weather prediction development for wind speed, power, and forecasting. There were a number of motivations for this task, or for this work package. One was the observation, certainly within the U.S. Department of Energy, which is my home federal agency in the United States. They're the ones that operate the national laboratories. There was a recognition that in an effort to make improvements in models, there was a tendency to overlook historical data sets that could be of considerable value, so that sometimes people simply forgot about them, and there were resources expended doing much the same work as had been done previously on a few occasions. And so one of the components of the mission is to communicate what is going on around the world within major field studies that are oriented toward improving numerical weather prediction, and also simply collecting information about ongoing measurements that are available from tall towers that can be used for validation. Next slide, Gregor. So, Gregor, okay, yes, thank you. So, I'm sorry, yes, thank you. So my slides are jumping around a bit. Okay, so we're with respect to identifying some of the data sets that are available. One of the components of work package 1 was to collect, as far as we could find them, tall towers that could provide ongoing information over an extended period of time that could be useful for validating improvements to numerical weather prediction models. This was a significant effort under this task. It is now essentially complete, and we are there are a couple of items that we have yet to add, but we think that these are a resource. If you go to the website, you can find this table and links to the sites from which you can obtain the data. And so we hope that that will be a useful service. Next slide, please. Gregor, could I have the next? Thank you. In addition to the tall tower catalog that we have produced, we also, associated with this work package, have compiled a list of field campaigns. This is updated on an annual basis and is intended to capture both in the historical record available data sets, but also in particular to highlight current and upcoming large-scale field measurement programs that could provide data that also would be very valuable in validating numerical weather prediction models. So, for example, The second wind forecast improvement project, which is shown in the left column on this slide, was just completed in the US. That is a study that has provided an extensive array of nested measurements from the mesoscale down to the microscale within complex terrain in the Columbia River Valley of the northwestern United States. This is a data set now that is archived and is available through the DOE Data Archive and Portal in the US, and is a data set that is available to anyone who would like to use it. Similarly, there was a large-scale study, or actually a series of studies associated with the new European Wind Atlas, and the largest and final study in that series was the study at Père de Galles, which also is an extended study with lots of detailed information about the behavior of wind in complex terrain, which also is a potentially valuable data set for the validation of numerical weather prediction models. And so we have made an effort to communicate this to the global community through these catalogs. Next slide. We also have a collection of, and let's see, is this, we're still on task 1, I believe, Gregor. We also have a collection of the Wind Power Prediction Project list that is available through the website as well. And again, more detailed information is shown on this next slide. Next slide, please. All right, and I guess one last thing I would say before we move to Work Package 2 is that part of the objective of Work Package 1, which was not fully realized in the first phase, but which we will be moving systematically toward in the second, is not simply to leave these catalogs of observations that are available to the community, but also to develop some procedures, example validation, numerical weather prediction validation exercises, and benchmark case studies that can be made available to the community so that we can begin to perhaps settle on common approaches and system and conforming comparisons when we evaluate the various models that are used in the various agencies and weather forecast services for wind energy. And with that, we can move to Work Package 2.
Yes, thank you, Will. Work Package 2 was led by Pierre Pinson and Caroline Draxel, or is still led by them, though the de facto lead for quite a while was Jakob Messer, but he found a new job at Anamo Analytics now. And staying with that information portal that we built, one of the things that Work Package 2 did was to deliver a whole number of test cases, because often developers of short-term prediction models were complaining that they couldn't get hold of power data. And here we have several existing benchmarks together that can be used to actually develop a forecasting model. But that is the main task of Work Package 2 was actually the forecast solution selection and the trial and benchmark execution. And we are trying to put out a recommended practice on that one within this period, so within the year. That might not totally be possible, but we are still working on it. And you see, it's a quite complex setup to choose a new vendor, and it depends not only on how much money you have, but also on how much time you actually want to devote to that selection process. and how compatible your computer systems are, and so on and so on. That will be in 3 different parts. One is the general forecast solution selection process. The second one is then if you're actually doing a benchmark and trial, how do you set up a good trial? And the third one is how do you actually evaluate this trial? Corinna Merlin especially did a lot of work on that, and also had some papers on the recent workshop in, that's actually wrong, that must be 2018, in Stockholm, on the wind integration workshop, and they will be available through the website again. And more important, next week there is the webinar on the forecast solution selection. Corinna Merlin, Jeff Lerner from Weisela, and John Zack are going to be the presenters of that one. Then in work package 3, we had George Graniatakis and Corinna doing the lead. And one of the major things that came out of it was probabilistic forecasting and how to use it. So there was a paper on understanding uncertainty, how we can actually move from deterministic to a probabilistic world, and a whole lot of use cases of that. We also had a collaboration with the IEC subcommittee 8A. They have a work group on renewable energy forecasting, and we're working together with them to make a technical report as sort of state of the art of forecasting. As I mentioned, the main result of that work, of work package 3, was a list of uncertainty forecasts in the power industry that had quite a number of people contributing, and is now a open access paper in Energy's journal. And several people put then a more simple text together for the IEEE Power and Energy magazine. That also is going to be a topic of a webinar in 2 weeks' time, at the same time here on this channel. Then for phase 2, we are having some new objectives. And while we're doing this, I should point out that if you have any questions, please submit them through Slido and put in the code U719. That will bring you to a website that looks pretty much like this. And then you can type in your question here, and if the others are interested in that question, they can actually give it a thumbs up, and then we'll have a ranked list of questions for the end. So the phase 2 objectives are to have, some of them are actually pushed forward from phase 1. Most of them actually are continuing, but some is that we are again providing the guidelines for the implementation of forecast solutions. Currently, we're making the first version of that, but I'm sure that after 2 years of time using those, we will have some more input and we'll be able to put out a second version of it. Then we'll also build a framework for evaluation and use of forecasting model and solutions. And one of the topics that's coming up is how to actually put meteorological observations into grid codes for wind farm connection, because for the TSOs, it might be very beneficial to have online observations from those wind farms. but there's not really a standard, and we would be trying to work towards a recommended practice on that one. And as we did so far, we would like to do special sessions and conferences or dedicated workshops on it, and finally get a bit more to the bottom of the use of the propagation of uncertainty throughout the whole modeling chain. If you're more interested in forecasting, then I'd like to draw your attention also to a course, a massive open online course that is being put out by the University of Strathclyde, University of Glasgow too, in their Future Learn initiative. And in one of the weeks, Jethro Browell has put together a course content that also looks into deterministic and probabilistic forecasts. Then for the next phase, we already have some meetings scheduled. The kickoff phase 2 is in week 7 at ZAMG, the Austrian Weather Service in Vienna. And we will have a special session at the International Conference on Energy Meteorology 2019 that is going to be here near Copenhagen. And the task meeting directly after that conference at the 28th of June 2019. And with that, I thank you. As I said, please, if you have any questions, put them forward here on Slido. And if you don't have questions or just want to collaborate with us, just send me an email and we'll take it from there. Okay, but since it doesn't seem that there are any questions, we might as well close this webinar here. I will upload it on the YouTube channel and put in a list on the page from which you seemingly came. Then I thank you for participating and hopefully talk to you next time, next week again. Bye-bye.